We have that circle that will belong here. You open your compass to 40, put here, draw. You will go to that center mark, open your compass to 30, draw. Now we have two arcs without center marks. I told you that for you to know whether it's an internal or external, we do have two types, either it's internal, external, or it is internal. The external arc is an arc that when you complete, you see this blue one, if I complete it, it was initially like that. It's touching the two circles externally from outside. So we need to add the radius, meaning that the radius of this external arc plus the radius it is in contact on one side. On the other end is 25, which is the radius of an arc, plus another circle it is in contact with. It's like a person, you've got a hand, you touch someone here and someone there. You are touching two circles there. So the first part is 25 plus 40, 65. Next is 25 plus 30. For all external circles, I think this shape you can now look. Then you open your compass to 65. When you open your compass to 65, you will place it here. Why are you going to place it here? Because that is the radius I added to the arc. So I must put the compass here. Open to 65. And then I'll strike an arc. Construction arc. Very light, very faint. On the other end, 55. Put your compass there. Why here? Because that's the 30 I was adding to. So the 55 I need to place here. Open compass to 55, strike an arc. Also construction arc. And they meet. Where they meet, that is where you are going to go and open 25. And perfectly it will touch. Without leaving a gap, without going inside the circles. If you see there's a gap left or it's going inside the two circles or one circle, it means go back to your calculation. Or else your compass is moving. There's no way it can fail to touch. For all your external fillets or arcs, I'm revising, I'm not teaching this part. For the internal arcs, it's those arcs that when we complete, can you see what's going on here? Look at that 120 radius circle. It's going to enclose the other two inside. It's an internal arc. And the opposite is you subtract. The radius of the arc minus what it is touching, radius of the arc minus what it is touching. So what's the radius here is 120. You are going to say 120 minus 40. What's that? It's 80, right? Then 120 minus 30. Then you open your compass to 30 or to 80. Put, well, which one is 90? This one? Okay. You open your compass to 80 and put here. Why here? Because that's the radius of the circle I'm subtracting. 90, I put here, I strike. What's this? 80, right? 80 here for this one. 90 for that one. I strike. And then you come here, open your compass to 120, then you draw. As easy as that.
You say how long this should take us?
To copy this one, this is 25 marks. 25 minutes, 30 minutes maximum. You don't finish, leave it. Go to another question. Otherwise, 4 hours, you will be just wasting time on this one. Give yourself time. Even the one I'm starting tonight also is 25 marks. We expect you to spend not more than 40 minutes, not even more than 30 minutes. When you see that 30 minutes is approaching, leave it. Go start answering other questions, because whatever you put there, every line work is counting in drawing. We're counting you on neatness, accuracy, correctness, those things. So make sure that don't perfect on one. You will end up going home with one question. And that's the mistake students are making on all the modules. Okay. Clear. So that is what you can see there. And if you can take one paper here again, before I start the second chapter, give them one. Also look at question number, I don't know, 2 or 3, but geometrical construction. It's on number 2. One. Yeah, it depends, but every chapter is coming. So look at what shape they gave in this paper. This paper is April 2020. Yeah, right? All of us, yeah. April 2020. That shape is just a copy and paste. But show the construction lines. It's not just, yeah, figure 1. What's this figure 1? Diagram sheet 1. I think more easier than any. If you can see, there's circles, there's fillet, there's an hexagon there, which I showed you. I showed you how to do polygons. There's nothing difficult there. It's just do measurements, draw, you copy it and show dimensions. Examiner will tell you I need 8 dimensions. If you leave out your dimensions, you are losing. Those dimensions are also part of what? The 25 marks. It must be neat. Avoid erasing unnecessarily, and how you avoid erasing unnecessarily is to start by using construction lines. Clutch pencil 0.3, those that are learning drawing. If you are an expert, you can use 1 pencil, it's fine. You just ease the pressure, or you press too much if it's an outline. But consistency must be there. You must be very consistent. Same line weight all around, same thickness all around the drawing. There's no way one side is dark, the other side very light. If it's an outline, it must be bold, visible, and presentable. But before all that, you have to do construction first, because you're not sure. It's like you want to build a house, they start with a foundation. It is a footprint of a house to be built. There's no way they will just start building on top of the slab. It's a process, digging the trenches, putting the concrete footing, putting foundation wall, putting the hardcore, putting the slab, then you start building, then you roof and truss and all stage. It's the same year. Show the examiner that you went through the process to get this out. Then you'll get your marks. That is this paper. Take that one quickly. Again, look at orthographic, no, geometrical construction. You are keeping those papers for your revision. I think there's one for me. There must be one. We are on for geometrical. We're still on geometrical. I'm just finalizing. It's finished. Okay, fine. Look at geometrical and then tell me if there's anything you can fail to do there. Can you see? Yes. Neat. Short dimensions. If you read the question, it's either scale 1 to 1 or scale 1 to 2 or 2 to 1, double the size or half the size. You must remember that. If they say 1 to 1, everything is as is in real life. If I say 1 to 2, I'm saying that the drawing is too big to fit on the paper. Reduce it by half. That's the meaning of 1 to 2. Then if they say that 2 to 1, you are doubling the size because this drawing is too small. We want it to fit on paper and for people to see. All right, that's the other one there. And then we can take the last paper there. 4 different past papers I'm giving you. You have the recent paper they wrote, I think 2022. I don't know if I put it there. It's there. Yeah, that's the one. Yes. 2022 is the one they wrote last month. As well, you must look at geometrical construction for 2022, this last one. What shape came here? A shape and how many marks? It's around 20-25. That's what I told you, plus minus 20, plus minus 20. 25 marks. Insert 2 linear dimensions, okay? Then 2 diametrical, meaning diameter dimensions, and 1 radius dimension. 1 radius, 1 diameter, and 2 linear. Linear is center to center distances. That's a linear dimension. This is the paper they wrote, and I was teaching, and they have passed. I think I had 90 students. 3 groups, full-time students. Night class also, these ones next door. I was teaching them this one. They passed. This paper, yeah. Mm.
The nice thing about you is the motivate.
They have, we have to put motivation, otherwise, I don't know.
You're not teaching to prove that this thing is difficult.
No, it is possible, and I've taught here from 2014, and I teach all the modules in your course. I know them in and out from chapter 1 to last, but I can tell you that I've taught people with no knowledge, and I've proven to say they can do it. They pass. So even the day you came here, I'm like, yeah, you've never done drawing, you would do it. You remember? You were with Rene here. I said he can do it and he's gonna pass. There's no demotivation here.
This one, what is the ideas?
Where are we now? The straight line. There's only one, those are straight line, tangential lines. Are we able to see this sketch nice? If they don't give radius, it's not a sec, it's a tangent line.
Yes.
Yes, all these are tangential lines touching the circles on the tangent. Yes. They are not arcs, no. The arcs, they will say radius. So those lines outside, they are lines just. That makes this easier. The only one you can ask me is the 13. Can you see 13 radius? It's an external arc. Already you can see 13 is an external arc. Okay, I know maybe you're asking about the other one, eh?
The big one.
Yeah, the big one will be the distance in between this, the 2 circles from outside to outside. We can get that distance. Yeah, they have given 120. That's the diameter of that arc. Yep. So radius is 6. 25 Mahala. Max. I say it's Mahala Max if you know what you're doing. Otherwise, So last week I started with the orthographic projection and we went through a lot. Unfortunately, my recorder was not working nicely and I was disappointed because I taught for a long time and then the volume is going, coming, going. But we'll do our best again. And for now, you can keep the papers away so that you listen. And I just need us to use, which one will be easier to do? Not the cut ones. Am I meeting you on Thursday? No, next week. Because I can't go straight to the cut one, it will confuse you more.
Okay.
Yes.
We are, you said,
Yeah, we are doing that. Yes. But first I must say, have you done drawing before? Fine. You've never done drawing. Were you here when I was teaching orthographic projection?
Last week.
Okay. We'll start there. No, I'm not choosing any paper for now. Just a concept. You need the concept. I mentioned last week that we do have 2 types of projections they can ask you. One is called first angle projection, and the other one is third angle projection. So examiner can ask you either to draw in third or to draw in first, or he can give you views in third angle projection. He wants them to be drawn in first angle projection. Or he can give you in first, he wants them in third. Either way. The layout is very important. You have to think in 3 dimensions. Because when we come to orthographic projection, I think Mr. Rene will teach you more in pictorial. You have to take note that there's 4 quadrants when we are doing projection. And in first angle projection, the first quadrant here, not there, here on your left side, is where you put your front view. And this front view, according to the standards, South African Bureau of Standards, is the right-hand side view. Meaning, any object that I'm going to ask you to draw in first angle projection and I want its front view, you must stand on its right-hand side. Can be your car, a house, anything. If I want the front view of your car in first angle projection, obviously you'll be viewing it from its right-hand side. But if I want the front view of your car in third angle projection, you'll be viewing it from the left. It's the same front, it's not changed. Who is changing? You. Position. That's the meaning of front, and when I say it is a right view, because you're viewing from the right-hand side. Any object, it's the same front, it doesn't change. But what changes is where you are standing, because orthographic projection is a drawing method where we extract views from the solid, from a three-dimensional form. We're extracting three important views. And the three important views, the most important is what? Front. And they give it to you every time. There is no way they won't give you a front. The front is always provided, because the other views are taken from the front view. Okay? Then, in first angle projection, the top view sits here. And then here, next to the front, is what we call side view or left view. Because this is right. There's no way that one can be right. It will be a left view of your car, not the front part of your car, the side. When you stand at the corner, there's a front and there's a side. And then when you want the top view, you go on top and view. The shape you see, you draw there. Then in third angle projection, they just swap. Top view comes here. The front view goes to the bottom, and it's not a right view anymore, but left. And next to the front, you're going to get your right view. Very important basics. I tell you, even those people that have done this, they are doing mechanical drafting, they confuse which one is first, which one is third. And what I want you to remember is that examiner can give you drawings in first angle projection. Then it's going to say redraw in third angle projection. You are just going to swap your views. Front will go to the bottom, because the front is the same. Even the appearance is the same. You will see what, I think last week I drew something. I need to use space here. I drew a block in isometric. I made it nice. I put a rib, which is a support. Okay, they will give you the thickness. Then I made it more nicer. I put openings here. I said this is a drilled hole, and that side same diameter. It was like that. The way I've drawn it, if I want to do first angle projection, this is my right view in first angle projection, and it is my front. You will stand on the right hand side of that block. Whatever you see is your front view. Then if I need a left view, yes, then you draw it on the left.
So actually front is not really front, it's actually right.
Yes, in first angle projection. Then if we need the top, we go on top. But the same block in third angle projection, I drew it the other way. I said, okay, this is first angle projection. What if it's third angle projection? Then I went on saying that you could have it drawn that way. The rib is behind, you won't see. the openings, maybe you see one there, another one hiding. I don't know if you understand. The front has now moved to the left side. It's the same front, but now can you see? I'm viewing it from the left. And this makes third angle projection, makes this front view, left view, and it's the front in third. This is first.
Okay, so you can actually draw the right front in the first, so this one is actually the third.
Yeah. Let's do this. You see this quadrant, ne? I'm gonna put the front view here, which is the right view. You getting all your measurements? What we do, we draw a small circle of diameter 10, and then we draw a line, and another line tangential there, and another line here. These red lines I'm drawing are just lines that will keep the views apart so that they're not touching each other. So it must be construction. Now, if I know the sizes of that front, I'll do it here. It's the L shape, it's got a rib, and there's opening here, center line, and hidden details. You see, you won't see the holes there. Those holes are going to be in hidden details. Let me get my chart. Are we understanding there? I've done the front view. So now if I want to do the front view but in third angle projection, I'm sure it will be the same. I don't know if you can see what I can see. Yes.
Are those holes will you be able to see
From the top view on.
from the top view only?
Correct.
So why are you?
You know what? Drawing is like what you see on the top must be reflected in all the other views. If the house has a door in front, how is the door looking like when I'm on the top? You can't show it here and not show on the other view. It's wrong. Yes. So all
means you've actually taken a slice
yes.
right to that. And
All the views will have a rib, you know, a word. All the views will have circles, but in different directions. Even the circle is hidden. You have to show.
Okay, this hole here is this one, but
You mean this one here?
yes.
Yeah.
That
It's
is
when you
this one.
stand here. It's this one. That
What
one.
about that one?
This one.
The other one.
This other one.
Yeah.
It's behind.
So how do you show it?
Then you won't show it's in the same diameter. Yeah, they're in the same line. So if I see this, I see what is there. Unless the diameters are not the same, then I'll also show the
I
other.
think that's the question, because if you look at this, then they say, okay, how many holes? You can't.
I'll finish. Immediately I draw the three views, you will know how many there are.
Ah,
That's the point of orthographic. You want to show us how many? Maybe there are 4. Here you can't know until you do the top view. Correct. So I've done this top front view, and I wanted to say that the front view for left view, look here, left. Can you see that it's still going to be?
same.
Yes. Same. And that hole there, same. But different position. Now, I'll give you the top view. And for you to get the top view right, you project from the front. The edges are the same. You see those edges are projecting. Even the holes if you want, and the center line, and that will project. Okay, no, it's fine. And then this side here, it is the width of your drawing, you know that. And that width, it is viewed here. This is your, whatever dimension it is, you know. Then the rib, okay, I've got that edge, which is solid here. The rib is in the middle. Can you see from the top, the rib will be seen like that. Then the hose now, I need to put them in their correct position. And here. So what the examiner is going to give you is not that no, just these two. Project the missing view. Without that isometric there, because if you're not drawing, you'll be visualizing already. You have created a 3D in your head, and you already can see the left side. So they won't give you a 3D view. I'm now going to project, because I'm teaching orthographic projection. I'm now going to project the left view, not using third angle projection, using first angle, but you know it's the same way in third as well. Except that in third angle projection, your 45 degrees will be here. In first angle projection, our 45 is in this quadrant here. 45 degrees line. So what are we going to do here is to project horizontal lines from the top, from the front, going to the left side. And because you are learning drawing, those that are learning drawing, it's wise of you numbering the corners. You see those corners, don't make the dots. I'm emphasizing, that's why I'm doing that. If you do that on your paper, it's, you know, it's clutter. I'm emphasizing. But you can say, okay, this is corner number 1. It's just below this one. This one also I'll number it 1 because they're in the same age. You come here and number this one 2, and that one also 2, same line. You come here, you number 3, and that corner 3. There's a hole here. How can I number it? It's this and that. Maybe it's 4, 4, 4, 4. Why same number? It's 1 set. You do that and make sure you draw small numbers so that examiner can't even see. Light, it's for you. But if those that not drawing, this is not necessary. Then you come here. All right, there's 1 and there's 1. When I come down here with these projection lines, you can see my arrows there. What is 1? Can you see 1 is this corner? 1. This one also will be 1. This one will be 1. That one will be 1. In the same line. You go to 2 and 2. There is my projection line. There is 2. There is 2. There is 2. There is 2. 3. This corner is 3. That corner is 3. When we come to a circle, you know we are going to mark 4 and 4. You mark, you know, up and down. You can't mark in this way because we need to go that way. So it's 4 and 4. Again here, 4 and 4. Then we start to project. To get the view right here, is number 1 meeting with number 1 coming from that side. Making sure that 1 hits 45, then up. Go and meet with 1. Where they meet is point 1 formed for the left side. The shape will be formed itself. You go in number by number, and then the shape will be formed. The shape I'm going to create here is the shape that you're already seeing that side on your 3D. So let's project that. Left view. I'll start with number 1. 1 and 1. So go through this 1, passing through 4, passing through 2, and out. 1 at the bottom, passing through 4, 4, 3. There is already a line. Can you see the 2 lines for number 1? You come here. Where is 1? 1, 1, 1, 1. Fine. Take your lines to 45 and up. 1, 2, 3, 4 lines representing 1. The first one is here, and it goes through 2, and it goes through 3. This line represents 1, 2, and 3. So this line will meet with this one here. And at the bottom, it will meet with 1 here. Can you see? Go to the next one, this one and that one. These 2 is not for the bottom. I think you can see it's for the rib. Can you see the 2 is for the rib? The 2 is for the rib, so the rib that did not go to the bottom. The rib starts on top. So the only line I need for 1 is this one. For these 2, I'll go with that, through number 2, out, then up, then get 1 here. The next one here, go through 2, up, get 1 here. You can go the way you use these lines. Why I'm going, because there's also for 2. You just extend. Then it's 1 this side. It's 1 through 2 through 3. You go with 45, there, up. Then it must meet with 1 here and 1 here. It's 1, 1, 1, and the shape is formed. How do you do that? Connect. You have created only the base. This that I've created is this. With the 2 points for the rib. You can see this point and that point. It's these 2. Then we go to 2, because 1 we're done. Number 2, there's 2 here, there's 2 here. This line for 2 is still there. 2 here will pass through number 3, and then we take it there, leave it. Come here, look for 2. It's 2, 2, 2, 2. The same lines. So the 2 on top here will go up and meet with 2 here. That side. This is 1 and 2. You can do that if you want. Next, 2 and 2. You go with that. There's 2 here, there's 2 here. 1 and 2. This one is 1 and 2. 1 and 2, 2 here on top. Then the last 2 here, you go with that, you go up. There's 1 and 2, then all the way up, 2. Where it meets with the 2. This face you connect. And the rib connects. It's 2 to 2 to 2, you connect. There's 2 to 2, 2 to 2, 2 to 2. You connect. You look at there, there's the rib. This 2 is that, and there's a rib. By projection, not by looking. So if you know this, that won't be a problem. Because what Rene will teach you is from this to that. Pictorial, there's isometric and oblique, where we take from orthographic to 3D. You're building up the shape, you see. So what is left here is just the holes, ne? Yeah, only the openings. How do we get the openings? There's the whole 4 already is here and 4 at the bottom. Fine. You come here, start with the center line, project the center line. Up until 45 degrees, there is your center line. This center line also 45 degrees up. So if I need to position this here, I already know that it's a through hole, you know, it's in this thickness. That is the height of, or the depth of the hole. Then here, the diameter is from here to here. That's why I said 4 and 4. So from the 4 on top, when it hits there, you go up. From the 4 at the bottom, when it hits 45, you go up. You have already created the hidden line this side here. This is the center line. This is hidden line. On the other end, same things, 4 and 4. You go with that 4 to 45, up, 45, up. You do a center line there, and you do a hidden detail. I want to tell you something. Of the 3 views, if you've shown outlines here, there's no way it can be outlined again. It's like you're looking at somebody's face, you see the eyes round from the front. When you come here, I don't think you see circles here. You won't see my eye round. That's the meaning. If you've seen round things in one view, the other views, they'll be hidden details. And that's what it's proving to you here. It's finished. This is 2-dimension. The main topic of tonight is what we call auxiliary views. It's not this one, but it's all about projection, but they call those views auxiliary views. Auxiliary views deal with shapes like prisms, pyramids, octagonal prisms, octagon pyramids, a square, different shapes. I just forgot, they're somewhere upstairs. Maybe next week I'll bring them. They're in form. Those shapes are in, solid form. That's why this chapter, they call it solids. If you hear people, solids, solids is something else. They know. we deal with a solid shape. And I give an example of this duster. I say, okay, this is a solid, but this duster is a rectangular prism. You hear me? It's a prism. Why is it a prism? It's parallel. All the edges are parallel. A pyramid is different because a pyramid can be rectangular or square, but pyramid. These are the things you also have to know. Or they can just say that it's a prism, which is this one. When I say prism, it also can come to octagon prism or pyramid. If it's an octagon prism or hexagon prism, you have hexagon drawn, then parallel. Prisms are parallel. It's a prism. But we don't give you sitting like this. Yeah, some questions, yes, but most times the examiner gives you tilted. That solid is sitting at an angle of 30 degrees or 60. Then project the front, the top. The front is always given. Project the top on the left or the right. All right. This same one can change to be, I can change this to a hexagon what? Pyramid. They converge to an apex. That they can give you whether it's sitting at an angle or it's sitting flat. That's what you see in these papers now. So we need to choose one. I don't know which one I can choose that I think it's easy that I can do on the board from the papers. Eh? Especially because there are other people learning. I didn't want to go through a cut one. You know, the advanced questions is when they cut a solid, where you ignore the part that has been cut and just show the things that are not cut. But we'll see. I looked at 2022. I think it's the one I can help with. Let's see. You know what's going to make me do 2022? Because it's got a prism and it's got a pyramid on top of it. I know it's cut, but we'll start by dealing with it without cutting, and then I'll come and cut it. If I show you this one, you'll be okay. But we'll do even next week. I still need to do one more. Then you can practice, and you'll see from there. So, this is question number 2 or 3. It's 25 marks. Just to copy the 2 views given is 5 marks. But you really have to know what are these 2 views that are given. There's always a front view from the 2 views given. The other view is called, yes. The auxiliary view is a shape that determines how the solid is looking on the base here, on the sides. So if it's an octagon, you see, like the way we can see there, you see there's octagon and there's a square pyramid. There's a square pyramid cut. And the square pyramid is sitting on a hexagon what? Prism. How do I know that it's sitting on? You can see there are 2 shapes there. And one, there's no way you can draw your front before you draw your auxiliary shape. The auxiliary shape is how does this one look on these faces? Is it a triangle? Is it a square? Is it a what? So you always have to focus on the auxiliary view first. And that is what we draw first. And when I was teaching chapter 1, I emphasized that, guys, don't think I'm playing with the polygons. I was doing the set squares here, showing you which one is what. It's because of this chapter. Because in this chapter, if you don't know the concept of those polygons, you can't get it right. How to draw an hexagon from outside the circle, across the flags, across the corners. So the hexagon that we see here, how are you going to know that it's inside the circle or it's outside the circle? Can you see? It's not that easy. One, because the circle is not given to you in the exam. The only thing that will help you, and you must listen there, you must look at the center. You see the center will pass on the flat, the main center line. The main center line will pass on the flat side, you see. The main center line is taking you to the front. I will draw it on the board. It's taking you to the front. So it's across the flats. And it's that one that is drawn outside the cell. This one here. So in other words, like you are guessing, but you need to try both ways. And when you do across the flats, it's not giving you the side length as 35. Then you do the across the flats. But it's not easy to pick up. And that you'll see as you draw. So I'm going to stick to first angle projection. I don't know, I like it too much. But it's not that it's every time going to be in first angle projection. Let me read this question. Check the question. July 2022. I'll go to question number 2. Okay. Question number 2 says that figure 1, diagram sheet 1 attached, shows a truncated is tilted, a truncated square pyramid on an hexagon prism, tilted at an angle 45 degrees in the horizontal direction. Draw to scale 1:1 and in third angle projection. So I'm forced to do third angle, yes, because the same third angle projection. Fine. The following views. And I want you to remember that whenever they ask for third angle projection, they won't ask for left view. Because the left view is the front given. The front will always be given. And I said in third angle, the front is a left view. So unless the question is contradicting, if they just ask for left view and they say third angle projection, it's wrong because the front is a left view. They can't ask for left again. The only question that will ask for a left view is if it's in first angle projection. So we are going to do in third angle projection. We need 2 views. First, you copy the views that are given, which is auxiliary view, and the front view. You get the point. Auxiliary views is those hexagons and the square. And that's where I'll start with. But how do you know where to draw on the paper? You need to plan. Planning means understanding whether it's first angle or third angle. So it's third angle. Where are we drawing that bottom? Bottom corner, bottom left. Because it's the front and auxiliary view. And I told you that third angle will do this. Top, front, right. Third angle projection. So what is given there will be in this quadrant, together with the auxiliary shape with the front here. Then we'll start to project and get what? Whatever is being asked. Very important to understand the question. So if it was first angle, then I was going to draw in this top quadrant. I was going to leave space for my top view. Many students, due to poor planning, are going into the exam room. After 1 hour, I'm done, but running short of space. You can't start. You've wasted time because you didn't plan, you didn't understand the question. So let's just copy that. I'm going to leave small space up and leave a bigger space down for my front. Let's say we close here. It's fine. Look here, they are saying 45 degrees. It's tilting to which side? Take the paper. I'm going to draw the hexagon. When I was teaching hexagon, I told you that the side length of the hexagon is the radius of the circle. That's what I taught. And that's what is in the book. So 45 degrees, maybe this center line, 45 degrees to the horizontal line. Then at a convenient space here, you need to plan that my front will come and sit. I'm going to do my auxiliary view here. So let's say I put my other center line at 45 again. If this line is going at 45, this is 45. If this one is going at 30 degrees, the other one will go 60. They must add up to 90. So it's 45, 45. Then after that, open your compass to 35. Can you see the side length is what? 35. Hexagon. Radius 35. Open your compass and draw the circle. After that, I don't have the set squares, but what you are going to do, you need to draw a line here. Check. This line must be at an angle of what? 45. And measure the length of the hexagon. Half, half. So that is 35. It's half of 35 and half of what? 35. We do the same here. Straight there. Next, 60 degrees set square. I don't have the set squares. I don't know where they are. You're supposed to have 2 of them. We're saying that this is going at 45. Can you see? So when I said last time that it must be 60 degrees. Can you see the way I'm holding? Those that never did drawing must check. $60 degrees to the 45 line. To draw a tangent line here, and another 60 degrees, 60 degrees, 60 degrees. So here, I'll just flip this and rest it here and do 60 degrees. Then I slide to the other end and do 60 degrees. Making sure this is 45, because that is the angle given to us. Okay. So I'm going to just draw those. We know that we use those set squares. 60 degrees. Make sure it's tangential to the circle. What I mean is it must be touching the circle on the tangent. This side, tangential to the circle, 60 degrees. On the other side, 60 degrees. On there, 60 degrees. Why did I use this method? Why I use this method is because the center line is passing on the flats, though it looks bent. It's passing on the flats halfway. Okay. Are we clear there? You can go back to module 1 and learn the solid, the shapes of polygons. I'm going to project. How do we project? You project these corners and that corner at 45 degrees. This one is passing through this one. This one is together with that one, and then that one. These lines I'm drawing in red must be construction lines. It looks very tilted, like not 45 degrees. You know, it's a freehand sketch. It looks too tilted, but I'm gonna fix. Then, what are we doing there? You are drawing that base, ne? You know the hexagon is the prism at the bottom. That one here. So the lines that you have just drawn, make sure that at a certain position, maybe even here, I'll start here where there's space. 45 degrees, 45 degrees. And then you outline the edges. This one is a center line. You see why I said you start with the auxiliary view? This is part of a front. So I need now to do the one on top. You see that one on top, which is the pyramid. To do the pyramid, I need to draw here, that square. And that square, what is the diameter? 38. When I was teaching, I said the side length of a square is the diameter of a circle. So you draw the circle of diameter 38 inside here. So let's say our circle is this one. I mean diameter what? 38. After you draw that of diameter 38, I'm gonna use black for the inside so that you can see. You can see the corners. We're going to use 45 degrees from that corner outside. You must check if it's the one for outside or the one for inside. It can be inside or outside. Everything that is just like that. And making sure that it's touching the circles on the flats. But I'm sure this one is across corners. Can you see the center line? I think it will be inside the circle because it's on the corners. If it's in, yeah, it is across the corners. Please fix that. The square will be inside. It's from here 45, 45, 45. Why am I choosing this method? Because the center line is passing where? On the corners. After you do that, it has been cut. You need to know where it was cut. Though they didn't specifically give where it was cut, we need to do it here from the front. So at the front, you're going to project that to the bottom. I think it's a bit outside. Yeah, I'll try to make it outside. It's somewhere here and somewhere there. That's where it starts. And after that, you're going to measure 80 length. Can you see from the bottom? Is 80 millimeters to the apex. So if that is my apex and it's 80 from the bottom, then I'll connect this to there before you even cut and connect that to that. Then the other corner is this one in the middle, which is going that way. What is next? That 45 degrees, can you see the 45 degrees line? It's where the cut is. So they say that it was cut maybe here, straight there. That is how it is cut. I'm going to remove a cut like that. Just assume that piece is not there. It's been chopped off. But they have given you exactly at the position it was cut. Can you see the 45? So it's, I don't think it will be a problem there. Fine. We have copied that for 5 marks to copy. And that 5 marks will mark you on accuracy, neatness, correctness. You can even get 1 out of 5. If it's dirty, it's not correct. Just that 5. Now we need to fight for 10. 10 here, 10 there. And how do we get 10? Those that were here on last week, Tuesday, I said there's an important center line on your auxiliary shape, which we use, and I'm using green line here. Center line, this is the one in green that I called Y line last time. And how do you know that it's this one that is important? Because there's also this center line on the auxiliary view. There's this center and there's that center. The one parallel to the width, you can see this is your width, ne? Yes. I always say the center line parallel to the width is your Y line. And then when you look at this question the examiner gave you, can you see the XY? It's the same line I'm talking about, but my method is to work from the middle, to work from the center, and it's quite easier than working from outside. This is the very line I'm drawing there in green. But if you've done drawing, you'll see that it's much easier, because many people from metric, they say, that one is long. But this one, we work from the center. When you work with this one, you work from the right, left to right only. But the method is similar, you will see. Yeah. So that XY line, it's this one. But please, I don't work with it outside. I move it to the center of the auxiliary shape. And even if the object was facing here, maybe sitting like that, I was going to take, you know, if it's sitting like that, I was going to take this as my Y line. Why? Because that is the one parallel to the width, not to the length. Just remember that. And once you locate your Y line, this topic will be easy. How do we do it now? I'll start with the bigger solid. Which one is the biggest solid here? The bottom, yes. We are going to number the way we did. I can say, okay, I'll start on number 1. in the center. Then I can go to this corner, that corner I can say 3, then that corner I can say 4. Because this one and that one I can just say 1 and, if you want to 4, 5, let's go that way, 6, it's up to you. Or you can say 1, 2 and 2, 3 and 3. It's easier that way because it's symmetrical. So I usually say, if there's 2 here, I put 2 on the other corner. If there's 3 here, I put what? 3 on the other corner. Once you number, bring the numbers, come here the way I did on the previous one. I went straight, this is 1. When I come straight down, which one is 1? It's this one and that one. 1, 1. There's 2, straight with your 2, where is 2? It's taken us here. If you follow your 2 nicely there, it's the one bringing here 2, and at the bottom, 2. We are talking about the outside one first, not the one that is even cut. Okay, then 3, there is 3. And there is what? 3. Then it's 4, there is the corner for 4, there is the corner for 4. Remember that your cut, for you to get it right, you go up and get the cut here. I think it was cut that way. You'll see exactly how it was cut. It's sitting like this. Fine. I'm not talking about the black one. Let's finish with the bigger solid. You know, the way they get confused with this one, when you take lines from all the solids going in one direction, it will confuse you. Deal with solid by solid. Start with the biggest one. Finish. Even the previous one I did, you know, I ended with the holes because they were the smallest ones. So in here, I'll start with the base. And they want us to do what? Third angle projection. Meaning that we are looking for from the right-hand side. Right-hand side of your front. This is your front view. Students are messing up, they go project the auxiliary view. No. Auxiliary view is just to help you get this and to help us mark. You'll see how I use the auxiliary view for marking. Only for marking. So, right view, you are looking from here. I want you to tell me which of the 2 edges of the blue one, this top edge or the bottom edge, will be visible to you if you are looking from that top one. You agree? The top edge. But remember that even I'm drawing this edge here, it is an hexagon when you look from that side. So you have to show me an hexagon there because you're looking now on the face of the hexagon. But how? Yes, we know it's the top one. So we focus on 1, 2, 3, 4. You agree? We take our lines that side. Construction lines, you take number 1, go that side, number 2, 3, 4. Then, at a convenient space, create your Y line, anywhere where it's free. Y, 1. So these lines, make sure that they are construction. The red lines are construction. I'm just outlining so that they see on the recording. Fine. Now, to start marking, to know where number 1 falls there, is to come to your auxiliary view. And make sure that you refer to Y line. That's why I said Y line is important. So when I talk about this one, it is this one. Is it on the Y line or it is away from the Y line? On. So when you go with number 1, mark on Y line. Then we go to number 2. We know that 1 goes to 2, 1 goes to 2. Yes, that is this point. So we need 2 points representing 2 there. But these 2 and that 2, how far away from the Y line? You take your compass perpendicular to the Y line. That distance. That distance is the distance you're going to mark on the right and on the left of the Y line. And then how do you know that this number is right, this is left? You look at the Y line the way we are looking. You see the Y line. This is right hand side. Can you see? Of Y line. This is left hand side of Y line. So any corner that will be on your right here must be on the right there. If it was facing this way, I was going to say left and right if it was facing the other way. If I was looking from the left side, I am looking from the right side, so it's right side of the Y line, left side of the Y line. You take that distance with your compass. You come put here, you mark 2, you mark 2. It's 2 on the right and 2 on the left. It's that 2 and that 2. Then we go to 3, this 3 here. We have already taken the line there, but where is 3? Also same distance, can you see? That same distance. So it's just below 2. So you can either take that distance, otherwise it's the same. If you know, just come and align. Okay, so 3 is here, below 2. Oh, 3 is here. And the last is number 4, which is on the Y line. There is 4. If we use it straight there. And you agree that you are going to see all the edges because you are looking from here. And this piece that is sitting is smaller. It's smaller, so there's no corner that is hidden. That thing, prism, the pyramid is smaller, so I'll see how all of these are connected together. And that's what you do there. You come with your ruler, 1 joining with 2, 1 with 2, 2 with 3, 3 with 4, 1 with 3, 2 with 3, and that one. You see the shape, it's the hexagon shape. But we have only done the top edge. Well, now we need to do the bottom edge. But when we come to the bottom edge, you must be very careful there. When we come to the bottom edge, there's the half that will be hidden. Half and half hidden, half outlined. Because that one is fully outlined, which is the top edge. The bottom edge, 1 half is hidden, 1 half is outlined. Which half is hidden, which half is outlined? You go again here. Looking at where you are looking from. Can you see we are looking from that side? I think I must stand. I'm looking from, if I use this main center line, do you know that this side is right hand side, this is left? That's how you are going to see. In fact, it's just this half. This half, let me use black, that you are going to see. This black half. Why am I using this black half? It's the right hand side half. Even if I don't go there, I'm standing where I am. The right hand side half, because we are looking from the right. So I will see how 3 joins with 4 and how 4 joins to 3 up to the half. But how 2 goes to 1 and 1 to 2. It's on the other end, on the left far end. So you need to know which one. The way I'm standing like this, it's right, left. You agree? So the right half is outlined, the left half hidden details. So if we are looking from the left, it's the other way around. You follow the main center line, not the Y line, the main center line. The main center line says this is your right hand side. If I put the line in the middle, right, left. So the right half is what is going to be solid. Okay, so let's project 4, bottom now. 4, 3, 2, 1 at the bottom. 4, you go horizontal line straight. 3, and then 2, 1. Marking, you either relate to those numbers that are there or you come back to take measurements. It's easy. This one here will just be below 1 name. You see here, below this one here, this one here. This 2 here will be below the 2 that was already marked. So I'll go with this line for 2 and it's here, below that 2. And the other 2 is here, below the first 2. 3 again below the other 3. You come here, you extend, there will be 3 here, and then mark 3 here. We are at the bottom, edge, and then it's 4, which is below the other 4, and it's on the Y line. There is 4 here. And I've already mentioned that we are seeing the right half. Okay, you are going to come back here. You will see how 4 goes to 3. And here. And then 3 to 3, it's a vertical line. You will see it. How this 3 joins with that with that is solid. 3 is acting like almost in the middle. There's no way you can have a hidden line on the outside edges. Drawing doesn't allow. There's no way it can be hidden here. So 3 to 3 is a solid line. And that 3 to 3 here is solid line. What else is solid? Because we are looking from here. It's 4 to 4. I am looking here. In other ways, I'm saying this, that, being that is the right half. I'll see how 4 goes down to 4. Because I'm looking from here. And I'll see how 3 goes to 3 and how 3 goes to 3. Which I've done 3 to 3, 3 to 3. The next one is 4 to 4. But I'm not going to see how 1 goes down to 1. It's behind. It's on the left end. We are looking from right side of this shape. So 1 to 1 is what? Hidden details. Then again 1 to 2, 1 to 2, hidden details. That is the left half. From this 1 to this 2 here. Hidden details. And this piece here, hidden details. Then how 3 goes to 4 and 3 goes to 4, there we have done 3 to 4, 3 to 4. It's solid. You have created the prism. Now you need to create the pyramid, which means the one that's sitting on top of that one, the black one. With the pyramid, what are we going to see most when we are looking from the right hand side? You can start with the bottom. Bottom numbers is which one? You have this point, you have this point, you have that point. You see the 3 points for the square pyramid. You start at the base where it is sitting before you go to the apex. The apex is chopped off, but it's very important. We need it there. Though it's chopped off, you need to project it. Why? Because it will guide us how the lines are going to start from the base going to the apex. But in any way, I'm going to start with that, and I'm going to say this is A, B, C, D. Can you see what I've done? I'm not using numbers just to avoid confusion. So if this is A, you saw I brought this line down here. So this one is what? A. This is B and D. When I bring this line to the bottom, it's this point here, B over D. And then we have C. When you come straight here, you get what? C. Can we see the points? After that, you can take your apex, horizontal line. There is the apex. Avoid this, ne? You need to push it far. This is not allowed, like where you project and draw through the auxiliary. Fine. How will I know where A is here? I need to project A with the horizontal line. Okay. I need to project B and D, right? Horizontal line. Let's say it's lying there for some reasons. I need to project C. Those are the 3 lines. To know where they are back here. Where is A? On the Y line. So when you go with this line for A, you come and say, oh, A is here. Coincidentally, with 1 is fine. Where is B and D? You take your compass again, perpendicular to your Y line. Which one is on the right? B, right of Y line. D will be on the left. So that distance you mark, you go with that line, you come and mark on the right here, there is B. Right of this Y line is right, left. So we mark B and we mark D, same distance. Why? Because that distance here is the same distance here. And the last point is C, which is on the Y line. When you go with point C, you just go and mark on the Y line. And we are going to see only the bottom half. How? Why am I going to see the bottom half? I'm talking about right half of the main center line. I'll see D to C and B to C. I won't see how A goes to B and how A goes to D. It's on the left half. We are looking from the right side. And that's what you do there. So we'll see C to B and C to D. But from here to A, hidden line. From there to there, hidden line. Now, those corners, there are 4. Where are they going to? Apex, yeah, there. But we'll chop them at their points. For now, you need the construction lines going to the apex. So I'm going to go to D and draw a line, construction line, and B, construction line, and A and C, they are already there. How will I know which one was cut where? Like C, as it was going to the apex, it was cut here. Can you see at the corner where it was cut? Go with your line at that cut, you go with that line, and then make sure that you go and get C where it was cut. If you follow that line nicely. This is C going to the apex. It was cut here. Which is maybe if you draw it accurately, I don't know if it's going to be a horizontal line, I think it should be. Then when you come to this point here, it's for B and D. Can you see? The cut for B and D, you take your line there. Then D and B, as they are going to the apex there, they will be cut, with that line. You can mark where, maybe here and there. That's where they cut. Bring the line from the cut. But this question I've seen, it's a straight line here. The memo is a straight line. Why? Because they say that 1, 2, 3, they were cut like a horizontal line. If you check here, it looks like a horizontal line. So all your 3 points are lying in the same line. I'm not going to force it, and you know it, this question. It has come before, not in this year, some years back. So the memo for that one was just that C was here, B and D was here, A was here, then it was cut here, straight. Then you outline that, which is B or D. B also you outline. C to the apex, you will see. This, there you will see, because you are looking from left. You will see how C goes to the cut. You will see how B and D are going to the cut. But you won't see A going to the cut, while A is on the far end, behind, on the left side. So this point A to point M, this is our A here, with the other A at the bottom, this is the one on top. It's going to be this point here. There will be A somewhere here. It's going to be a hidden detail. But C to C here is solid. This one is a solid line. And you know why I'm making it solid? Because it's near the eyes. This line here. It's the right half. It's this C going to C here. This line. This D going to D on the cut, I'll see. B going to B, I'll see. The only one I won't see is the one at the back. You see how many lines are there? Too many lines. But the good thing is that once you get this right, it will be easy to get this shape here, top view. How is it going to be easy to get the top view? You are only going to put your 45 degrees line here. Take your Y line to the 45, bring it here. This is the Y line on the top view. The way we started with the base is the way we are going to start here. What am I doing? I'm looking for top. So if I'm looking from the top and I'm talking about the blue shape, which is the prism, which between the top edge here and the bottom edge is fully visible from the top. Between this edge and that edge is the top edge. So you are going to project from there, from the top edge first. Number 2, vertically up. Then 3, then 4. What next? You either use marking or you use that one. If I've come with number 1, this is number 1 on the top edge, that's 1. Where was 1 here? Oh, 1 was on the center line. So 1 is here. You come, you mark 1 where they meet. You see what we call projection. It's 1 from there versus 1 here. Where they meet is a point you have created. Otherwise, you can still work with the marking. There is 1 on the Y line. There is 1 on the Y line. Done. You go to 2. You can either take that distance, come here, you mark, or go back here and get 2. 2 is here, 245. There's my other 2, 245. Where are they meeting with these 2? Here and there. You got your 2 and the other 2. Then you go to 3. There's 3 going up. Where is 3 here? 3 and 2 together. You can see. 3, 3. The other 3 is on the other end. Then 4. 4 was on the Y line. 4. Done. Looking from the top, this is going to be solid. Though it looks off, but it must be, same shape. So let's just fix it like it must look normal there, straight there. Then this line here must come straight to there. Yeah, it was what? 3 and 2.
Can you have this mark back, please?
Yeah, I just want to finish now. Okay, so you're done with that, then we can do the bottom one. The bottom one is number 1, number 2, 3, 4. You come here, number 1, number 2, 3, and then 4. So if I'm looking for 1, it will just be below this one here. There, number 1. Because the other one was here. Then number 2, I'll go up, and then in line with that 2, I get 2 here. And on that end, I get 2 here. Number 3, 3 here, and 3 here. Number 4 at the bottom is on the center. There is number 4. And already I said we are only going to see 3 to 4 to, but now you're looking from the top, so you see which one. The 1 to 2 and 2 to 3. You understand the highest point. You won't see the lowest point. In short, we see the outside part. It's how this one goes here, and how it goes there, and how it joins there. Then the inside one from 2 to 4, from 3 to 4, it's hidden details. What else? How 1 goes to 1, because you're on the top, you will see solid line here. How 2 goes to 2, you have already done that, 2 to 2. The only one you won't see is 4 to 4. Where is 4? There is 4 to 4 here. That should be hidden details. So we have created the bottom. I'm coming to do the other one after break, just to finish up on this one. Because what we have created is the base. Then after break, maybe 10 minutes talk, then I'm done. I like talking and then finishing, then you can practice. Yeah. So I'll need to edit the recording because it's cut now. Now, yes. Okay, we can go.
It's most, is